GUI development and which algorithms we were using.
So first of all, we'll tell about our graphical user interface.
Yes, so we use the Qt, open source cross-platform framework for GUIs, plus a plugin for Eclipse. Yeah, our goals for the user interface was made simple and easy to use, no need to read manuals, just get in, select what you want to use and start using it. So basically you are able to select which one of the plugins or the logic modules you want to use, just with a simple combo box. And then you're also able to configure how the cubes are bound to the virtual objects, just with a configuration dialog. And finally you're also able to see the result of the plugins. So here we see a very early stage mock-up of the GUI. And then now we have a bit more advanced mock-up. And finally you can see the actual main GUI, where you can see you can just select with a drop-down the module, and then you can start and stop the acquisition of the image. And finally you can also configure.
When we click in the configure button to choose some module, it appears a new window with the number of contours that the cubes have and its corresponding virtual object. This window allows us to configure this correspondence and save it in a file for using in the next execution of the program. At the beginning, the application didn't work perfectly, like you can see in this screen. Because when we put some cubes in the webcam, it shows duplicate image and from the different modules. But unfortunately, we could fix of the problems and it works now perfectly.
So the next part is binary map. So it was one of the logic models that we have implemented.
If you know what I mean. So binary math is one of the modules we have there. That was implemented by me and Michael over here. It's a module that allows you to combine digits into binary numbers and perform binary operations with them. So, some cubes represent digits, like 1 and 0, and some cubes represent binary operations, namely addition, and, or, XOR, and NOT. Oh, right. Okay, so that's how it works. I guess you all know binary operations, and we take two numbers, we perform operations, we get the output, and in our applications, the numbers are composed by cubes, and that's what makes it a lot of fun. Yeah, here you can see an awesome 3D image, which we don't have in our graphical interface, but that's how the module is done. However, we have some drawbacks in the module, or they have features. We call them features. So there's limited amount of cubes at a time because of the limitations of the camera. So only short binary numbers can be composed at the moment. And one operation is picked from, if there are numerous operations there in front of the camera, only the first one is picked and then operation is performed. So you can see only one result there.
Okay, so next up is color palette. It was also a logic model that we implemented.
So our graphical artist is always looking for the perfect color. Right wanted to take a different approach.
So we stepped back and we thought about how was this done in the old days by actual painters and how is it done still by actual painters. And what they do is they have this wooden palette and a brush, and they move their physical objects to get the perfect color. And it turns out iCubes is the perfect solution to do the same thing. Rodrigo will tell you about it.
As you can see, we can mix the virtual and the physical part. These cubes, each one of them represents a color, the red, the green, and the blue, and it's formed into values that represents the RGB values in it.
So this is how it works. This is what you see on your computer. You simply move the cube on the surface and the slider moves. And as you move all the three sliders, you get the resulting color by simply combining components from the RGB model.
So next up is recognition. So how did we recognize it first? And how did we complete it?
Okay, so here on the screen we have an overview of this process. The initial picture from camera goes through the pre-processing stage. When we try to extract the contours from the picture and find square-shaped objects, the contours. We keep only the rectangles and triangles, and then we try to detect a cube. And the cube is a square which has a triangle within. This is our definition of cube, and such as this it is used in our algorithm. When we have cubes detected, they can go into the further process to find their properties. This is the reprocessing. As you see, we go from the raw camera picture to get grayscale and thresholded image, which is very suitable to finding contours and squares and other geometric objects. This is how the detection of the contours look. On the left, there is some initial programming, initial stage, which is how it should work. And on the right picture, there is a final example of the process. So you have contours drawn onto original image, as it is recognized on camera. Okay, so here we have an overview of what exactly is produced by this recognition. What are the properties or features of the cubes? We have the ID, or the number of contours, which is defining the cube. Then we have center coordinates, which is the location of the cubes on the camera, its width and height, and orientation. Now show you how we are producing IDs, or how we count the number of contours. As I said to you before, the cube is a square which has a triangle within it. So the big black square is a cube, right? Because it has a white triangle on the upper side. And within it, we have another rectangle. On the outer level, there is one rectangle. Then inside, there are two black rectangles, and even further inside, there are another two rectangles. And if we count this, sum this count together, we get an ID of 5. This is how it works. Another more simple example, right? We have two white squares on the upper level and one another inside. So 2 plus 1 is 3. Maybe you've seen the movie Inception, where it was dream in a dream. We have a square in a square, and sometimes we were really crazy about it when it didn't work. Yeah, but finally we managed to get it out. Okay. A little question for your quiz. What is the idea of this cube? What do you think? Yeah, it is 1. Another question. What is this ID?
2.
Yeah, 1 plus 1 is 2. Great. And now go. You know? Yeah.
10.
I think so.
Yeah.
Yeah. Great.
Great.
Who's that? You should get a cube. Come pick one.
Yeah.
If you wish. Okay. Okay, thank you very much. That was for my part. I'm sorry I've forgotten to thank the authors of this algorithm, Maxim and Alexei for the idea, and Anders and Ilya for implementation.